people need to consider their options. They need to look at, all the different technologies. They have to start with an understanding of what are their goals or what are their challenges, and what are the technologies that fit. I mean, it could be that solar PV is the right fit. It could be that solar thermal is the right fit. It could be that biomass or hydrogen. Or I think we are in this energy transition where, on one hand, it's exciting because, as you pointed out, Jigger will say, is deploy, deploy, deploy. There's a lot of activity.
Today on the Clean Power Hour, solar thermal for institutional and industrial applications. I'm Tim Montague. Welcome to the Clean Power Hour. Check out all of our content at cleanpowerhour.com. Please give us a rating and a review on Apple and Spotify. That helps others find this content. My guest today is Matt Lensink. He's a repeat guest. He is the founder of a company called Phoenix Solar, and we're going to talk all about what he's up to. Welcome back to the show, Matt.
Thanks, Tim. It's so great to be back. Real pleasure, a real honor to be invited back on your great podcast. So I know how hard it is as a fellow podcaster to do what you do, and to have, I'm not sure we've had a repeat guest on our show, so it's a tremendous honor to be back on yours.
Yeah, I've had a small cadre of repeat guests, and you're in good company. Jigger Shah is my all-time favorite repeat guest. He's been on the show 3 times, and you're filling some big shoes.
Clearly, I'm now sweating profusely from my palms, but I'll do my best.
So I grew up doing solar thermal in my backyard in Albuquerque, New Mexico. Making hot water solar panels. And it was all the rage in the 70s, 80s, and 90s. And then this thing called PV came along and kicked its butt and pretty much put the thermal business out of business for a while. But you're back. You've got a tracker technology from Sweden, a company called ABSOLICON, which is a little awkward. I'm going to spell that. It's ABSOLICON. And you have become a exclusive licensee, it looks like, in North America. What's the story, and why did you go after this technology?
Yeah, and I'll start by rewinding the tape about 12 months, going back to our other business that we spoke with you about in a previous episode, CEM Engineering, where the C in CEM stands for cogeneration, and most of we described ourselves as thermal power engineers, which really meant, we were focused on all things molecules and all things heating and all things, steam and hot water and thermal oil, but primarily from fossil fuel, sources. Not so much oil or coal anymore, of course, but primarily natural gas. And we were doing what we could to help our clients use less natural gas or do so more efficiently in the case of combined heat and power or cogeneration, and had a good 20-year run doing that. But the world, as we know in the energy space, is continually evolving or transitioning, and we really started to look at our industrial and institutional clients who had a need for thermal energy, but didn't have an appetite to continue to burn hydrocarbons that come from fossil sources long term. And so part of our, focus strategically was looking at ways to diversify, and we looked at RNG and biogas and hydrogen, but they were already kind of mainstream, and so we were also looking at, new and emerging tech, and we had a team which included our founder, that was looking at a whole myriad of different technologies. And a co-op student that we had, through a paper from the Renewable Thermal Collaborative, hit upon this particular solar thermal technology. And we'll talk perhaps about the nuts and bolts about it in a minute. But what was interesting was, they were doing solar thermal energy in ostensibly northern Sweden, about 300 kilometers or 200 miles from the Arctic Circle, so very far north. And so we have a Swedish-speaking thermal power specialist in our office, and he gladly picked up the phone. in hindsight, he was laughing to himself because he knew that the Swedes spoke perfect English. But he brokered the first couple conversations, and we fell in love quickly with both their technology and also their business model. And their business model was kind of a franchise model in that these solar thermal units are so large they're not flat, and they can't ship in a dense enough fashion to make it economical to make them in Europe and ship them to overseas. And so their model is more to have a production line that they really developed that's quite slick, and have those throughout the world close to where the projects are going to be. And so over the last 12 months, we've been building a relationship with them, and we are the exclusive manufacturer and supplier, distributor for Canada, and we have the opportunity to pursue projects anywhere in the U.S. as well. So we are hopefully going to be making panels domestically in calendar 23. We're now building out a market and building out projects and a pipeline around this technology, really focused on institutional and industrial energy users who have on-site thermal needs. And so, in summary, because that was a lot, really, we were at CEM looking for alternative technologies. We stumbled across this interesting technology and interesting business model, and so we built out a separate company targeted specifically on that market and that technology.
I've been doing a series on solar thermal now, various flavors, and much of it falls in the CSP category, concentrated solar, and this too is concentrated solar. You're using a trough, I believe, right? And so it's a parabolic trough that runs along, and then there's a pipe that gets concentrated light shined onto it, and you heat that up. But in this case, you're also doing tracking, which is, I just think, very cool. And trackers, of course, have swept the field, so to speak, in PV, although not at northern latitudes. The gain that you get from a solar tracker, from a single axis tracker, is lesser in the northern latitudes, meaning like north of northern Illinois. Up into Wisconsin, we would switch to fixed tilt. What's the story with this tracker, and what were the competing technologies that you considered and then settled on this ABSOLICON technology?
Yeah, I think it's important to kind of add a couple items for context. One is that because we came from the thermal world, there's all of these realities and body of knowledge in the solar PV world that we're kind of like kindergartners. Like it's all brand new to us because we never really had exposure to the solar PV industry, and it's matured and developed and got a lot of great people and a lot of great experience. So, it took me a little while to even remember what D&I stood for and what it meant and things like that. So really coming up to speed on all of this stuff. And as we've been doing that, one of the things we've learned is that, there's really three tranches to technology in the solar thermal space. As you mentioned, there's the concentrators, the big, utility type projects where if you look at it from Earth, it looks like a big concert with a bunch of people kind of looking towards the stage, or sometimes I say it's people kind of worshiping the sun god or something. But they're reflecting, and they're making steam, and they're driving a steam turbine, and it's a 20 or 40 or 60 megawatt utility project. And then there is kind of the lowest quality heat tier, which is the pool heaters and the vacuum tube technologies that are really more economical, that are getting lower grade heat, but have lower installed costs. Where this technology really fits is in the middle band, and that's why we're specific about our focus on industrial and institutional heat, where they need heat at 160 degrees Celsius, or over 300 degrees Fahrenheit, or they need some steam up to 110 pounds per square inch. And so, we have been getting familiar with what else is out there in terms of that middle tranche, and there are different vacuum tube technologies. There are different parabolic trough type kind of concentrators. But what we really like about this one is some of the things that are really interesting is it's got quite a high efficiency in terms of I think it's upwards of 77% efficient in terms of capturing the energy from the sun and converting it to heat. It's got a solar key mark certification. So I think that's kind of a first of its kind in terms of getting a European designation like that. And it's enclosed. So some of the larger solar concentrator troughs are maybe open. This one is fully enclosed with glass, and glass that's been tested in Swedish winters and tested against hail and other things like that. So there's a whole list of things that really we were drawn to. And then on the business side, I mean, they've been around for about 20 years. The first 15 was on R&D, and the last 5 was on really building out a business and a business model and technology and a marketing effort. And so the support we've gotten from them in terms of key relationships and pursuing a market in a focused way, because the technology alone is not good enough. We need the marketing support and the back office support and the engineering support, and it's been just tremendous. So, and I think some of that you can't pick at the outset. You just have to experience as you go along, and quite frankly get lucky every once in a while as well. So.
These troughs are about 18 inches across, it looks like. Is that right?
Yeah, so we're going to have to do some translation here, because a lot of their units of measure, of course, are all metric, because you got Europeans dealing with Canadians, and so we're very comfortable. So it's about 1 meter across, which is 3 and a bit feet. So it's
Okay.
3.5 feet. The length is about 20 feet in length. And the depth is about 16 inches, I think. So
It's hard to tell when you see photos of this, but we'll put links in the show notes to your website, of course, and the ABSOLICON website. And but yeah, it's hard to tell. This is definitely on the same scale as a solar tracker.
Right.
Obviously, the row space is lesser, and there's less shading concerns than with a solar tracker. But because in trackers, our row spacing is 13 feet, row to row, typically. This looks more like maybe 1 meter or less even.
Yeah, and that will grow. That will grow as depending on where it is, right? As I'm coming to learn, of course, the shallower the angle of the sun, then the wider our spacing is going to get. But yes, we can get them a little bit, and it's that's part of the design process, is to optimize, how many can we get versus what's the shading going to be.
And can you tip them? Is the whole row tippable so you can tilt it towards the sun?
Not once it's installed. I mean, you could, if you had an angled roof or something, of course, but not. There's only the pivot of the trough itself.
But there's no reason from a design perspective why you couldn't do that. It looks like.
Yeah.
But
Correct. You could provide a racking system that would allow you to bias it in that fashion, and then they could pivot in that regard. That's right. Totally.
yeah.
Yeah.
Because in northern latitudes, that would be advantageous.
That's right. And then we have to think about things like wind loading and snow loading and all those things that structural engineers will help us out with. And the higher they are, the more they're likely going to catch the wind. But that's definitely something that we've started to look at in different applications.
Sure. So, and you have to forgive me because I don't know a lot about how thermal, what the load is and how it relates to the space. But with a large industrial facility for PV, we can typically, like let's say a factory, we can approach 50 to 75 and sometimes 100%, generate the load, the electric load of that facility with a rooftop solar array, say a 2 to 5 megawatt solar array. And then the customer is saving on the order of, say $50,000 a year to several $100,000 a year if they were to buy a project outright. Depends, how it's financed, PPA versus
Right.
ownership. But in the thermal world, you're replacing some fossil machine, right? A gas boiler or an oil boiler that's making hot water for heating or other industrial processes. And are you able to, and maybe you haven't walked through enough opportunities yet, but are you able to do kind of a swap out? Are you able to decarbonize their hot water system?
We go into the opportunities knowing that we will not be the only technology solution on their decarbonization journey.
Mm-hmm.
Said a different way, we can displace some of their load, and we can add a thermal battery or thermal storage, depending on what term you're familiar with, and so we can. In the ABSOLICON nomenclature, they call that solar fraction. I don't know if that's common in other, but essentially that's a measure of how much of the thermal load can we displace, and certainly with enough real estate, we can maximize that. But it becomes somewhat there's an inflection point where more dollars in panels starts to lose out in terms of return. So we work pretty hard in that early stage discernment to find the optimal size and optimal tie-in, because somewhat analogous to voltages with electricity, thermal energy has different levels as well, and this technology is, because of potential heat losses in the panels, is most optimal at high temperature hot water. We can do steam when it's required, but the efficiency drops off a little bit when we make steam. And so we're always looking at where within their process, if it's a hot water system and that's all it is, beauty. We tie in as high up in the system as we can. But in some cases, let's take a brewery example, of which we are looking at several, and our European counterparts are looking at several as well. Often they're making steam at 150 psi in the main boiler room, and then they're distributing it at that level, but they're really stepping it down to 50 psi or 30 psi at the bottling facility or at the CIP process. And so that's really where we're trying to tie in, where we're really displacing kind of the right level of heat. But back to your original question, we go in with full knowledge and full awareness to the client that we are but one of your solutions. We feel we can deliver a solution that is on par with your current cost of thermal energy. And certainly as prices go up, and depending on your jurisdiction, carbon taxes either get applied or escalated, that gap will widen. And we deliver that thermal energy without any carbon footprint, which is contrary to what you're doing today, even with clean fossil gas. But definitely we're looking for, and that's where the CEM side can come in, we're looking for complementary technologies, whether it be electric boilers, whether it be biomass, whether it be biogas, other complementary projects or technologies that can target their scope 1 emissions, which is what everybody really is targeting. Most industrial and institutional sites have, by and large, eliminated their Scope 2 emissions, or are getting better and better and closer. But the Scope 1 emissions remain hard to get, and we acknowledge we are but one of the solutions to eliminate Scope 1 emissions.
Yeah. So let's just, dwell a little bit on a hypothetical here. Let's say I'm a hospital campus and, today I'm spending $1 million a year on natural gas. I have no idea if that's if that's anywhere in the ballpark.
Not far off.
And of course, it's changing, right? Energy prices are spiking globally, partially due to supply chain issues, partially due to the war in Ukraine. But both natural gas and electricity are going up in many parts of the world, including here in the United States. I assume you're seeing a similar trend in Canada. What's the word there?
Well, we're seeing the commodity itself go up, and I mean the current pricing is probably inflated and will come back down, is the general sentiment. But what is also very clearly understood is that here in Canada we have a carbon tax that's federally applied, and by 2030 it's currently at $50 a ton, and by 2030 it will be at $170 Canadian dollars a ton, and that is applied to all natural gas purchases. And so that line is very clear. It has a positive slope upwards, and what we're seeing, where we're seeing the interest in this technology is people who want to take back control of some of their energy, and they know that the sun is always going to be there. It's very clear what the DNI is going to be for their location, and they've de-risked a portion, whether they're buying it or they're hiring us to provide it as a service. They've de-risked a portion of their thermal energy supply over a 20-year or 25-year life, and that's really where we see the opportunity is to de-risk that supply.
Yeah. And so if I'm spending $1 million on thermal energy from fossil fuels, and I want to save money, everybody wants to save money, and I want to go green. I want to decarbonize my operation, what you referred to as Scope 1 emissions, which is essential, right? We have to remove 40 gigatons of carbon pollution from the economy in the next 20 years, and then another 800 from the dump in the sky, otherwise known as our atmosphere. But so the task is large, and the good news is we have the technology now. We just need to deploy, as Jigger likes to say. And but do you have a sense of, let's just talk best case scenario? In Canada, there you've got a carbon tax, so that sweetens the pot. What do the economics look like? What, this is a large facility you're talking about installing, and of course there are challenges around space and roof condition, or is there ground available? That's always a constraint that we clean energy professionals are dealing with. But paint us a picture of what does a success story potentially look like for a Phoenix solar installation?
Yeah, if we go back to that $1 million spend on gas, and I think it's important to point out that, solar thermal is a bit like, pick your artist, is a bit like Miley Cyrus. Not for everybody, but why, I don't know why that popped into my mind. But anyways, it's not for everybody. But let's say for $1 million spend, it is. Probably we can get 30% of the megawatt hours for that particular facility. And so on the thermal side, if we equate thermal to megawatt hours, we can get about 30% of that $1 million spend. So we're tackling $300,000 of that spend. right out of the gate, we believe we can get this is kind of after financing, whether it's self-financed or through as a service or through a PPA. Right out of the gate, we think we can get 10% lower than the spend. So we take 300,000 and turn that into 270. But where it really starts to pay out is that 300 is going to turn into, by 2030 or 2035 in Canada, that 300 turns into 600, and all of that growth then it goes to savings, because your PPA is a fixed price PPA, your financing costs are a fixed price, and so there's a little bit of a spread in the early days, but as soon as that gas price, whether it's through just the commodities market, whether it's through an application of a carbon tax or cap and trade, all of that spread accrues to those who've made that early stage investment.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and review. Back to the show. Yeah, that's the beautiful thing about renewable energy facilities is the fuel is free. And so the dividends are many. What else should our listeners know about Phoenix Solar? Who are you initially targeting? What industries and what geographies?
Great question. We are initially targeting geographically. We are mostly focused on Canada, in particular Ontario, for a couple reasons. One is just physically that's where we are, but more importantly, that's where gas prices are the highest and carbon tax is the highest. Our D&I is not great relative to, let's say, Alberta, but Ontario, Alberta, most of Canada is looking quite interesting for us. But there are relationships that we have that are causing us to look at different, U.S. opportunities, and certainly progressive organizations, whether it be institutional or industrial, are inviting us to look at opportunities in the U.S. But the kind of most interested types of sites right now are university campuses. Largely because they have a heating need and a cooling need that's driven by heat often. So they have a continuous thermal need, and they have a stakeholder body in the students that are really pushing for decarbonization. So in universities is a big one. And then breweries, so anybody making beer seems to be drawn to this technology. We have some good European case studies with solar thermal at breweries, Carlsberg, Peroni, Heineken, and then we have food processing. So those are kind of the three target areas. We're trying to figure out pulp and paper. We're trying to figure out mining, because you have a remote site with a very expensive fuel. But those are the three areas that are really starting to gain some traction. We have a kind of a multi-step process where we have an initial kind of field simulation where we can, and this is probably not unique to anybody in solar, but we can take a look at your site and kind of do a first pass analysis of how much energy we can displace. Then we have a dynamic simulation where we use our proprietary software, and we can model and really tie into the loads. And then from there we start to look at pricing out the installation, and do you want to do it yourself? Do you want to finance it yourself? Do you want to do it as a PPA, or what we're calling solar thermal as a service? Those natural kind of project development steps.
And the solar array needs to be in some proximity to the application, what is the rule of thumb around that?
It's got to be close, but it doesn't have to be terribly close. I would say within 500 feet is probably okay. One of there's in every site there's going to be what we call Solar Central, which is a control modular that separates the host site from the solar thermal field and provides control of heat transfer and control of the solar array. So that's a series of heat exchangers and pumps and valves and instrumentation. So that's typically going to be at the host site. But anywhere within 500 feet is probably, with the pre-insulated pipe that's available in the marketplace today, that's probably okay. And then often we're tying into, in Sweden, for example, in the city where ABSOLICON is from, the city itself has a big district energy system that spans the whole city. And we are on the north end with a solar thermal installation. And it ties in, and it's heating buildings all throughout the town. And so with good district energy design, that's becoming less and less of a concern.
And if I'm an EPC that makes my bread and butter by developing and installing CNI projects, is there an opportunity for me to work with you, or how? Let's talk about that. How do you team up, so to speak, with EPCs?
Yeah, our vision for Phoenix Solar is to put a solar collector on every roof or every piece of property where thermal energy is needed. That's our vision, and so to do that, we have multiple ways. I mean, if a client comes to us as Phoenix and says, "I want you to do it," we can bring in the CEM effort and do a turnkey installation, whether self-financed or we bring the financing. But at the same time, the core business is really to manufacture and sell panels. And so if there are other EPC or project developers or energy services contractors who want to deploy this technology but don't need Phoenix to provide installation or other services like that, then we can sell them panels as well. We're flexible. The core focus is building out the panels, doing a great job of that. Obviously, we'll help with installation and commissioning and provide long-term remote monitoring, but we're less focused on the build-out. We can do it, no problem, but we'll partner with other folks as well.
Is there an overlap in some of the technology? Like, for example, glass. I would imagine you're using solar glass very similar to glass used in photovoltaics. You want light to pass through on the first pass, but then bounce back on the second to capture more of the light at the source. And then, of course, you're making a lot of your product out of steel, I would imagine.
Yeah, it's a lot of stainless steel, a lot of aluminum, and there's really kind of three key components. One is the polymer coated inside of the trough, which is obviously very reflective. So that's a key piece of the supply. The tube down the center, that is a stainless steel tube with a special coating on it that captures as much of the heat. That's unique. And then the glass is somewhat unique. We're working on kind of local supply of that. Obviously it's got to as you said, let the light in, try to keep it in, and then also be able to resist any kind of hail or inclement weather. There is a control algorithm that if for whatever reason there's no demand for hot water, we turn, or there's a reason, the storm coming through, we turn the panels all the way over so the glass is facing down to protect the glass or to avoid the system from overheating, because that is a threat as well. So there's some kind of key elements there that are proprietary and are important, but then a lot of the frame and the rigging and stuff is aluminum or carbon or galvanized steel that we'll be able to provide through our local supply chains.
Well, what else should our listeners know? We'll wrap up here in the next couple of minutes. Please check out all of our content at cleanpowerhour.com. Give us a rating and review on Apple and Spotify. And subscribe to our YouTube channel. Just click on the YouTube icon on the landing page at cleanpowerhour.com. But what else should our listeners know, Matt, and how can they reach you guys?
Yeah, I think what's important, and if people are listening to this, then they are already doing this work. Is people need to consider their options. They need to look at all the different technologies. They have to start with an understanding of what are their goals or what are their challenges, and what are the technologies that fit. I mean, it could be that solar PV is the right fit. It could be that solar thermal is the right fit. It could be that biomass or hydrogen or I think we are in this energy transition where, on one hand, it's exciting because, as you pointed out, Jigger will say is deploy, deploy, deploy. There's a lot of activity, but it's almost a little bit more challenging because I can imagine as a decision maker, you have all of these technologies in front of you, and it's not 100% clear which one is the right one. And so, obviously, there's lots of good advisors out there and there's lots of good research. I think that's the important thing, is to really cast a wide net, test a lot of different technologies. Solar thermal is not the silver bullet for Scope 1 emissions. It's definitely an arrow in your quiver, but there are many other technologies as well. So it's a big task ahead of all of us as part of this energy transition. And it's going to take all of our efforts and then some. And so we're just happy to have a seat at the table and have an opportunity. So if folks want to connect with us, probably the best way is phoenixsolarthermal.com on the World Wide Web, and you can find lots of information. You can reach out to us, and I got to get my email address. It's m.lensink, which is Len kitchen sink, at phoenixsolarthermal.com if you want to reach out to me. So, Tim, really appreciate, as always, you having us on the show. Real honor again to be a repeat guest and to talk solar, and feel very ill-equipped talking solar with an expert such as yourselves. But you've been kind to me, and it's been fun.
All right. Well, I really appreciate this. I'm a huge fan of solar thermal, and it is a vital part of the energy transition. So I say, let's grow solar. I'm Tim Montague. Have a great day, Matt. Thanks, everybody.